Do you know that beam column junction is a very critical joint in for the civil engineer structural integrity, and there is a chances that the structure can failure from the beam column junction. Do you know why this? The most of the cases that the development length of the bar is not provided as per the design requirement. So what is development length? How to calculate development length as per IS 456? Today we'll discuss in this video in depth about the development length, what is the purpose, what is the development length, how to measure the development length, and how to place the bar when we are doing the exact construction at the site, so that our structural integrity in between beam and column to be withstand and the structural to be safe for the longer time. So let's jump into the subject. What is development length? And if you're new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So first things, what is development length? See here in this picture, you can say this is the beam column junction, and how you will place the bar at the development length that is ensuring the structural integrity from of that beam column junction or the structure. But what is the development length definition? The minimum embedded length required for a bar within a concrete member to ensure proper bond and stress transfer. So it is the minimum requirement. What is the minimum requirement of the bar diameter? Bar length is required to transfer the stress and the proper bond in between concrete and steel, so that the structure can be safe for the longer time. And so whenever the beam column junction, whenever the beam rod reinforcement is entering into the column, what will be the minimum length in order to transfer the stress or the load to the column? That is the embedded length, and it is a very crucial for the structural integrity. Now what is the purpose? The purpose of that ensuring proper bond between the concrete and reinforcement bar, allowing them to act together as a composite unit. So what is our target? The whole structure should be a unit. So in order to make that unit, this development length is very essential, so that it can work as a whole, as a one. And the next is, what is the factors to be considered when we are calculating the development length? That is the bar diameter, concrete strength, yield strength, bond strength, and other relevant factors. In IS 456, it is clearly mentioned, and in the next section of the video, we will cover full details what is all this factor and how to calculate exact amount at the site. And then that is a code of practice. That is a, in India, code is IS 456 and other part is ACI 318. And then what is the location of structure? That is applied to all bars that need to be anchored within a concrete member. So whenever the stress transfer from concrete and the steel, that is the beam column junction is the very essential. So these are the location of structure where we need to use the development line. Then the structural integrity, that is ensuring that the structural integrity and the load transfer between concrete and bars. So these are the structural integrity. If the structural integrity will not form, is the development length is not proper or the less amount, then what will happen? Then the failure will happen. That is a permanent failure. That will be insufficient development length may result in bond failure between concrete and bars. And what will happen? The structure will be in collapse. So the structural integrity and the lifespan of the structure will be the less. And what is the unit? Unit is always the millimeter or centi-inch, whatever. Now we will check how to calculate the development length. For that, we need to check the IS 456, and IS 456 in clause number 26.2.1, the development length of bar is clearly mentioned how to calculate. See, here it is already mentioned the development length of bar LD is given. So this LD is not the lap length. Please make it sure, ensure that the development length and the lap length is not the same. There is a difference in between lap length and the development length. This formula is for only how to calculate the development length. Lap length, I will make another video for the lap length, how to place the lap length, what will be the lap zone, that is in details. But now focus on only development length, and it is not the same as the lap length. So here the formula is given, that is LD, which is development length, that is phi sigma s by 4 tau bd. Now, where phi is the nominal diameter of the bar. That means now if the beam reinforcement is 20 dia and it is inserting into the column, so the bar phi will be the 20 Then sigma s, stress in bar at the section considered at design load. See, Fy 415, Fe 500, Fe 550, it is mentioned in the drawing. So these are the stress for the steel bar, that is 415. That is considered in the design. That means if we are using 415 bar, the sigma s will be the 415. And if you are using 550, then the sigma s will be the 550. Now, this tau BD, that is design bond stress given in 26.2.5. Now, this is the design bond strength. And how you will can calculate the design bond strength? Now come to the next page. Here, see, in it is mentioned design bond strength in limit state method of plain bars in tension shall be as follows. So two things you just keep in mind here. It is mentioning plain bars and the limit state method. All we know that there is two design method, that is the limit state and the working state. Now we are considering the limit state method and the plain bar. That means it's not the TMT bar or the HOSD bar, whatever. It's a plain bar. There is no ribs. Okay, and in the tension member, it's not for the compression member. If the steel is in compression, this bond will not be followed. But how? Anyway, we see the grade of concrete M20 is 1.2, M25 1.4, M30 is 1.5, M35 in 1.7, M40 and above is 1.9. So these the design bond stress. Now suppose we are making M25 grade of concrete and we are using plain bars and that the bar is in the tension member. So it is considered to be 1.4. So here LD will be 5 is the 20, sigma s will be, suppose it's 415, 20 into 415 and 4 tau into 1.7 or 1.4 is here in our case. So this is the plain bar and the tension member we can find out easily. Now in our structure, it is widely used, that is the HYSD or the ribs bar. Now, how we'll calculate for the development length for the ribs bar? See, here it is also mentioned. Check. For deformed bars conforming to IS 1786, these values shall be increased by 60%. So, if we are using M25 grade of concrete and we are using ribs bar as per 1786, then 1.4 into 1.6 will be the my bond stress. So accordingly, if for in this formula, if it is a plain bar, we are using M1.5 for M30, but in 60%, it will be increased for 1.5 plus 0.9, that is 2.4. So here tau BD will be 2.4. So for the deformed bar, it will be increased by 60%. So whenever we are calculating, keep in mind this is for the plain bar and the tension member. So if it is deformed bar and the tension member, this value will be increased by 60%, and we will put in our formula, that is LD phi sigma s 4 tau BD, and we will get the development length, and accordingly the development length will be placed at the side. And now if it is a tension we are all discussing about the tension member. Now if it is a compression member, what will happen? For the bar, here again in the same clause of IS 456, it mentioned for bars in compression, the value of bond stress for bar in tension shall be increased by 25%. So if it is a plain bars and if it is compression, this 1.2 will be more 25%, 1.2 plus into 1.25, right? For this, if it is in a compression member, and if it is a compression member and ribs bar, then first this thing will be in 60% will be increased, then again it will be 25% increase in case if it is in a compression member. So this formula is very important, and it is clearly mentioned in the clause 26.2.1 of IS 456. Let's summarize. LD is phi of sigma s by 4 tau BD. Phi is the nominal diameter of the bar. Sigma s is the stress in the bar in the section considered at design load, that is Fy 415, Fy 500, Fy 50, and tau BD design bond stress. And where we can get the design bond stress? Here in the table 26.2.1.1. These are the plain bar and the tension member. And how we'll find out the deform bar? It will be increased by 60%. And if it is a compression member, again, it will be increased by 25%. So whenever you are calculating the development length of the bar, please make it sure that the whether it is in tension and whether it is in compression and whether it is a mild steel or whether it is a deformed steel, and that should be keep in mind whenever you are calculating the design length of the development length. So these things about the design development length consideration and how to calculate as per the IS 456. I hope you find it useful, and if you find it useful, kindly subscribe my channel and hit the bell icon so that everyone so that whenever I upload a new video, you will get immediate notification. And I'm waiting for your valuable feedback, so that from your valuable feedback everyone can get benefited. And again, thank you very much for watching me. And if you want to know anything about the construction procedure or the quality control procedure, please let me know in the comment section so that I will come with another more content like this. Thank you once again for watching.